near-infrared spectroscopy is fast, reagent-free and requires no sample preparation. To use NIR spectroscopy in routine analysis, prediction models are necessary. Hi, I'm Andreas, and in this video I will show you how easy it is to create prediction models with the OMNIS software. Prediction models correlate NIR spectra with the measuring values of a reference method, such as titration for acidity in edible oils. To create a prediction model, you need a dataset of NIR spectra and the corresponding reference values. Once you have measured your NIR spectra and added the reference values for them, go to Calibration and Evaluation in the OMNIS software and click on Create Quantification Model to start the process. First, select your dataset and reference parameter for which you want to create the prediction model. Give your prediction model a name and press Create. Then you can split the measured values into a calibration and a validation dataset. In addition, outliers can be automatically detected. Blue samples represent the calibration dataset, green samples the validation dataset, and red samples indicate outliers. Next, you can parameterize the quantification model by applying data preprocessing and selecting the wavelength range. In the data preprocessing window, you can choose between different preprocessings, such as detrend, gap segment with first or second derivative, Savitzky-Golay, or standard normal variate, SNV. For this example, we will use gap segment with first derivative order. Next, you can select the wavelength ranges of the NIR spectra which correlate with the reference parameter. You can enter the ranges manually or by pressing Activate Moving, which allows you to conveniently adjust the edge of the highlighted range in a spectra overlay. There is the possibility to automatically define or optimize data preprocessing and wavelength ranges by clicking on the Optimize Parameterization button. The final step is to validate the quantification model. Click on the Calculate button and the model will be calculated. In the top window, you will see the figures of merit for your prediction model. And you can choose the ideal number of latent variables that best shows the correlation between the NIR spectra and the reference values to avoid over or underfitting your dataset. In the bottom left window, you will find the correlation plot for the calibration and validation dataset. In the right window, you can view the influence plot, loading plot, or score plot. You can always go back to the parameterization step and modify your parameters and wavelength ranges to optimize your model. Once you are satisfied with your model, press the Save icon and publish the quantification model. Now you can use your prediction model for routine analysis. However, choosing the right preprocessing method or wavelength range can be a challenge, especially if you are not familiar with chemometrics or do not create models on a regular basis. But don't worry, the OMNIS Model Developer is here to guide you. Simply select your dataset and reference parameter. Give your prediction model a name and press Start OMD. The software calculates prediction models for you and lists the 5 most plausible ones. Colors indicate the quality of your models. You can use the models directly by pressing Save and Publish, or you can also review and edit the models manually. With OMNIS, everyone can create prediction models in no time. Ask for a demo now.